Welcome to our podcast on integrating immersive technologies in education. I'm Anna Scanlan from the IED Hub, which is a joint project between Munster Technological University Cork and University College Cork. And we're funded through HCI Pillar 3 investment, and our primary focus is to work hand in hand with industry to provide them with graduates who can hit the ground running on entry to the workplace. So if you want to learn more about us, check us out on www.iedhub.ie. And I'm here today with Hans Mühlmann and Mike Edgar from MTU Tralee, and welcome, lads.
Thanks very much.
Delighted you made the effort to come up. And I know that was a long journey, 2-hour journey this morning.
Yeah, just under it, but
in Cork and Kerry roads. But no, it was great to have you. We're just after having a little walk around the IED Hub and the facilities here in the IED Hub. I showed you guys our VR suite, our immersive suite and stuff. So I know you're very heavily invested in adopting immersive technologies into your courses. So I might start just by saying that immersive technologies kind of seek to use the most advanced digital technologies, platforms, to immerse students in an experiential kind of an environment. So whether that's augmented reality or VR or into rooms like immersive suites where there's 360-degree projections of different environments around them. But what I'll do now is maybe get you to introduce yourselves, if you don't mind, and just a little overview about what you do.
Yeah, my own name is Hans Mühlmann. My background is software development, specializing in games development. I am a research fellow on the READY program, which stands for Rethinking Engineering Education in Ireland. And similar to the IED program, we are also HCI Pillar 3 funded through the HEA. The READY program is an undergraduate 4-year degree course in mechanical and manufacturing engineering. And as one of the core pillars of the program, we are integrating immersive technologies into the engineering curriculum in various form factors. So if it's VR, AR, we use the term immersive technologies because it just kind of encapsulates all the acronyms: AR, VR, XR, MR. So yeah, we're a couple of years into the course, and we're really happy with the results.
Yeah, and I'm Mike Edgar. Similar to Hans, I've a background in software development, specialising in games development. I've been working with the Ready project since last October, and same role as Hans, looking at how we can introduce these immersive technologies, whether that be the headsets themselves or the different software solutions, to immerse students in the degree.
So yeah, thanks very much. And I suppose we're housed in third level education, and I suppose the wider public have probably heard a lot of talk about artificial intelligence, and a lot will be aware of virtual reality, VR. I mean, you can get the Oculus headsets and stuff in Smiths now, I think, do you know? But say, in terms of what you're doing, why do you think education has shifted towards such platforms as opposed to kind of traditional?
Yeah, I think we, on the READY program, we certainly been very lucky with senior management. So the head of School of STEM, Professor Joseph Walsh, and the READY director, Dr. Fiona Boyle, they're really driving this from the top down. It's a really forward-thinking and innovative approach to education as well, especially engineering education. But we are, with the success we're already seeing on the READY project, the engagement with the students, we're rolling out to different departments now as well. So I suppose it is just seeing the potential in the technology and not seeing it as, a kid's toy that you buy at Smith's and, you play it for a half an hour. There is real benefits to using immersive technologies in education. It's been proven over and over again, from knowledge retention to recalling knowledge better, the idea of unobtainable environments, so we can put the students in a situation that they might never find themselves in, but they still need to have that training. We find it very helpful for the likes of soft skills training. So we spoke about that earlier as well, about students might come in and they might be technically brilliant, but they might be able to speak at kind of different technical levels. So we're widely adopting it, and it's really successful.
Yeah, and I suppose, Mike, you actually mentioned accessibility earlier. We were having a general chat before we came in, and do you see VR? I mean, I kind of find it hard to see how VR would help accessibility, or am I wrong, or what?
Yeah, I think like with any technology, there's pros and cons with VR when it comes to accessibility. I think if you look at it from, like Hans was saying, being able to get immersed in experiences that you wouldn't normally be physically able to do, or maybe financially you couldn't travel to, let's say, a factory to go to a tour, that these technologies can bring you into these spaces, can let you experience them, interact with them, and it's that much more exciting than, say, just your traditional video or slideshow. But it's not without its faults. I mean, motion sickness is, especially with VR, a big challenge. What we found is if you introduce someone slowly to these technologies, so you say, okay, we're going to put the headset on you, put it on for about 15 minutes, then take a 10-minute break, then a half an hour, another 15-minute break, that kind of thing, that you build up slowly, that helps a lot of the cases. But it's not a be-all, end-all solution. There are still some people who, even after a couple of years, still get that motion sickness, and that is a challenge we've had to work with.
And I suppose to anyone who hasn't seen a VR headset or kind of doesn't know what we're talking about, it's almost like a helmet, for want of a better word, without a top. It just wraps around the eyes. So the person who's wearing it, they can see their environment to a certain extent, but they're slightly removed from it at the same time. So it is very enclosed. It's a very internal experience in one sense. And I know the first time I tried VR, I felt like I was falling straight away because I was floating.
Okay.
Do you know? So I found it hard to get used to. But at the same time, I can see applications for it in psychology, say, for coming over phobias, for introducing to spiders and stuff. But would you mind, Hans, talking a bit more about how you're using it for your engineering students?
Yeah, so we use a number of, I suppose, applications specifically on the VR front. Like Mike was saying there, it's not without its faults, and it's not the be-all and end-all of technologies. Sometimes a PowerPoint slide just is better. Sometimes a Teams call is just better and quicker. But wherever we can, wherever possible, we implement it. So say, for instance, Engineering Challenge 1, which is the very first module of the very first year, the first year students do, they design a Rube Goldberg machine. So what a Rube Goldberg machine is an overly complex process to do something really simple. So you'll see it on the old movies or cartoons, you know, the alarm bell rings, then something puts a ball rolling down a hill and it pokes a chicken and the chicken lays an egg, and eventually an alarm clock rings and the man wakes up. So what we have is just an off-the-shelf application that we give to the students. It's fully interactive, it's fully immersive. So they get a bunch of tools that they can use, and the lecturers set certain parameters then. So everybody is in is exactly the same room, not at the same time, but they have a start location and end location, and they have to traverse the room from one side to the other side using pendulums, push mechanisms, catapults. So there's engineering principles built in there. So like a push mechanism, it's not always perfect. So sometimes if there's a degree of error built into the application, so when a catapult shoots a ball, it's not going to land exactly the same spot every time. It might be off. So the students have to compensate for that to make sure that their application runs. And the students are graded on that then. So they can be as complex as they want, or they can be as simplistic as they want. Obviously, the more complex it is, the more marks they're going to get. But then the pass rate for them is, if the lecturer runs that, say, 3 times on the day of assessment, it has to work 85% of the time, or it has to work 2 out of the 3 times. That's how they get graded on that. And it's a fun way for the students to be introduced into VR, but also at the same time they are learning that engineering principles, and they also learn to manage themselves time-wise in the headset as well. In the classroom situation, when we are there with them the first couple of weeks, we manage their time, so we tell them after every 10 minutes take a 5-minute break. But unfortunately when they go home, or fortunately when they go home, we can't manage that. So that's up to them to manage their own time there. But yeah, Mike, you want to maybe...
Yeah, I suppose the other side of things we would be using VR for is, like Hans mentioned, the soft skills side of things. So we have another application called Body Swaps, and we have a number of training simulations that students can go in and, let's say, do a public speaking training session. So they'd be given 5 minutes to speak on whatever topic they want to speak on, and they're in this kind of virtual auditorium. And as they're giving that speech, the application is analysing what they're doing, their different mannerisms. Maybe I'm looking more to the left of the auditorium than the right. And by the end of it, it has a number of these analytics to help the students gain the confidence. And anecdotal evidence, but I know myself, I was involved in doing mock interviews for the second year students. And the confidence and the ability that the students had in the mock interviews compared to, say, where I was when I was doing my third year work placement interviews, it's like night and day. They are able to speak more clearly, they know their own skills, and they're able to kind of come across as, you know, competent and confident.
Yeah, so like there are two very different kind of case uses. So you've like the public communications here, just confidence, just their own abilities, and then you've very technical. And say, like, do they require any level of technical expertise to start using those softwares?
No, none.
They're entirely supported, aren't they?
Yeah, so day one, myself and Mike, we would get all the students set up with their own headsets. So each student gets their own headset that they keep for the 40-degree course. They actually take it home after a number of weeks.
I bet that attracts a lot.
We actually have a photograph of two students that went to a session, not a virtual session, information session that we held, and they actually changed their first preference over to Ready after the presentation. Yeah, so
do you get the headsets back?
We'll see.
At the moment, yes. So the students get their headsets day one, but we provide full support. So we get them set up. We make sure that everything's up and running. We support the lecturers as well in getting them set up initially, getting them trained up as well. So that if for whatever reason myself and Mike aren't there, that they can still continue on, and they very much take over after a certain amount of time. They take over and they would launch the labs then for the students.
Oh my God! So it's like peer passing on, so kind of peer training stuff.
Yeah, kind of like train the trainer. Yeah.
Something else as well is the headsets themselves. They're consumer grade headsets, so they're kind of built in such a way that you could go out, buy one right now, and with a little bit of effort, you'd be able to learn how to use it fully by yourself within a couple of hours. Mm-hmm. So that helps us a lot as well. That it's not highly technical.
Yeah.
And say from industry, I don't know if these students have gone out to industry yet, or are you getting feedback? So like doing better in interviews, that's a very kind of good metric, we'll say. But have you had external feedback as to
Yeah, I suppose we have. We've done a number of trial projects with industry partners as well. So looking at different immersive technology solutions for them to implement in their workplace. So they go on a 2-year work placement instead of just 6 months. So the first cohort will start in September this year. So they'll go through their work placements where they qualified. And they would be geographically dispersed. So they could be as far as Mayo, they could be, all over Kerry. But they would still be required 1 day a week to do their coursework. So the way we see that the technology is going to support them in that role is that the lecturers can do immersive labs. So rather than just talking to them over Teams, maybe gather everybody inside a virtual room, and you can bring in 3D CAD assets. So if you want to bring in, say, for instance, a tensile test machine, you can bring that into the space and the students can walk around it and interact with it, push buttons, experience it all. So that's kind of how we plan to facilitate that part of it. The industry side, there's obviously IP issues around there. So if you're walking about a factory floor with a headset with a bunch of cameras on it, somebody's going to ask questions. So there's challenges there, but we're working on them.
Yeah, and I think that's actually been kind of a successful implementation. The IAD Hub has managed with some very willing biopharma partners that were good enough to let a camera into their sites. And it's shown very specifically to a certain cohort of students who will be going out to their sites, but it really does familiarise them with the environment, and they can ask questions ever before they go out into the industry. One of the things I saw was a factory floor that was modelled. It was an actual factory floor and a working environment, and there was lots of operators sitting down, and the lecturer commented, he says, these people are not being lazy, they're reducing human contamination by particulate generation.
Okay.
So that gave the students an appreciation that when they go into these environments, you really do have to be conscious of your movements and what's going on, kind of different flow throughs, different walkways, different things like that. Just being mindful for looking out for how packaging is stored away. There might be cardboard allowed in one room, it might be excluded from another in case molds or fungi or anything like that will grow in it. So it's very, very good. So we've kind of spoke about VR, but I know you're doing so much more than VR. I know, Hans, you gave a demo to us last year when we gave a visit to ACE in MTU in Tralee. Some augmented reality.
Yeah,
so really interesting.
Yeah, we're very lucky with the partner that we have in ACE. The ACE suite that they have in the North Campus is used by the students for the practical labs when they're doing their gadgeteer and a few other examples as well. So we're very lucky to have them as a partner, and through them we have access to a whole lot of technologies like augmented reality, LiDAR scanners. That they have a a certified drone pilot on board, and with enterprise level drones, different camera setups, 360 recording equipment. So very lucky in that sense. So what we use augmented reality for is in production engineering, where students are tasked with building a little Lego Technics motorcycle. So one half of the group would get a headset to digitize the instructions and view it in a headset while they're building it, while the other group builds it just using the paper-based instructions. And then we compare the times of one group versus the other group and the accuracy of one model to the other one. But then in the interest of fairness and ethics, we swap them around. So each group gets access to it.
That's very good,
Yeah.
And have you seen any results yet, or?
We haven't anything officially measured yet. We're now starting to do that kind of the research part of it, kind of getting all the results black on white kind of thing, going through the ethics process. But just from timing the students on the actual models when they're building it, the students using the AR headsets are quicker and more accurate building the models.
Really?
Yeah.
And I'm going to row you back there now. You were saying about LiDAR.
Yeah.
Could you explain that?
Yeah, so LiDAR stands for light detection and ranging, and it's similar enough to radar technology, except instead of sound waves, it's sending out pulses of light like lasers. And the way it works is it sends out those lasers and uses the time it takes for those lasers to get back to measure the surrounding environment. So you'd see this technology used a lot in autonomous vehicles, and they would use a combination of the sensors, but LiDAR would be one of the primary technologies that would be used. And the way we're using it is that we have a LiDAR scanner that the students can go in, they can scan, say, the VR headset. They can bring that into a digital environment in VR using an application called Gravity Sketch, and then design an alternative version of the headset, which maybe looks a bit better or is more ergonomic or more comfortable. So kind of in that production engineering side of things, showing how you can collaborate together and design in more immersive environments.
It's kind of mind-blowing, really. Like, it's a very fluid conversation about some extremely technical stuff that you're doing. And I'm just wondering, in terms of your own background skills, how you got to this work role, because you both have different backgrounds. So for students that would be interested in doing what you're doing, so you're not lecturing, but you're supporting lectures, and I'd imagine you don't have time to lecture. It's very, very specific expertise, and I mean, I'd imagine you have to stay very current. Do you have to attend a lot of conferences, networking events, or I'm just wondering how someone might be guided into your kind of work?
Yeah, I think for me, I did the games development course, and at the time I had aspirations of, making the next big AAA game. That very quickly did not become realistic for me. But during that degree, I learned a lot of skills around design, games development, using the different engines like Unity and Unreal Engine. So I had those skills kind of in my back pocket. And I hadn't really considered VR, but for me, it was my own interest in learning. And I think it's something, regardless of what field you're in, if you have that appetite to stay up to date, whether it's, small things like watching a couple of YouTube videos about, oh, hey, look at this interesting thing someone did with a couple of sensors, to, like you said, going to conferences, looking at different research papers. It's not something I've as much time as I would like for, but it's a case of just finding what interests me, seeing what I can learn about it, seeing how maybe I could do a version of that myself. Pet projects are a great way to learn new skills. And from there, I just kind of, thankfully and luckily, kind of fell into this role.
Good.
Yeah, similar to that. I think my games development background really stood me in a role. It's again, like Mike as well, I had aspirations of making fantastic video games, but the market isn't there in Ireland at the moment. So it's kind of by chance that I landed in the role, if you want to call it that. But yeah, I feel if you're curious, if you like to explore anything, like Mike would say, pet projects there, if you're willing to break things, try different things, something out of the ordinary, certainly this is a career path for you. And like I say, it's through the forward thinking of Professor Joseph Walsh and Dr. Fiona Boyle, through their innovation and support, that we are able to do the stuff that we're doing today. Because any idea, like we've said, myself and Mike often joke, we had a harebrained idea, but then they fully support it, and we're allowed to run with it. Sometimes it works out, sometimes it doesn't work out. It's just a really interesting and evolving field.
It is, and I suppose my own background, I would have looked at how we learn, how the brain learns and stuff like that. So I would have an underlying concern all the time about how the brain adapts to its environment over time. I know there's concerns kind of in the wider research field. Professor Susan Greenfield, she's a leading neuroscientist, but she has expressed a lot of kind of concern that the brain throughout evolution has always adapted to its environment, and now it might start adapting to all these very immersive technologies in a way that reduces human interactions, communications and things like that. So I suppose we have to be very careful, especially when it comes to education, because just anecdotally from speaking to someone whose wife works in a DESH school here in the city, she said the school were very supportive of bringing in iPads into the classroom. Now it was primary school, and she says it was her nightmare hour was when the iPads had come out, because she says you'd lose all attention, you'd lose all focus, and very hard to bring that attention back into the classroom with the iPads. So I suppose the age thing is an element there as well. So these are third level students as opposed to primary. But do you see levels of distraction creeping in, or how do you manage that aspect? Or do you prepare the students for engaging responsibly with it? Is it something you've had to do, or?
Not really so much, just from my own experience over the last couple of years, where the students are not left to their own devices, but for the 2-hour engineering challenge one, where they're in the classroom, we find that most students, they would take the time allocated, if it's 10, 15 minutes, whatever slots they have, and they would work on the projects. You always have one or two that would open up a shooting game and or play pool in virtual reality. There is that element, but it is a case of self-regulation, self-management, maturity. Be mindful that we don't lock the headsets down. We purposely do that because we want to encourage the students to explore. And actually from that as well, we've had a number of students identify some really interesting applications to us. So like a kind of team working applications where they all can be in a room together. And we find that students that would kind of naturally be shy or reserved in face-to-face person, they would really come alive. Even if they're all standing in the same room together, it is that virtual element that kind of removes a barrier for them. So there is an element of that, but we encourage them to explore, to create. But there's an element of that that we can't really control. I suppose the same as somebody sitting in a classroom on their phone.
Yeah, and I suppose I'm thinking of parents or anyone that might be listening that might be considering getting VR for their son or daughter. That's entirely outside the scope of what we're discussing.
Exactly.
Because it is a very certain environment, and they're using certain apps, very specific apps for the purpose of learning. Some apps work better than others. Sometimes learning can be reduced based on the quality of the content and stuff. Now, there's great application for us in anatomy, but have there been any surprise findings or outcomes from what you found?
No, I suppose that the main issue, like Mike mentioned previously, is VR sickness. Unfortunately, there's not little you can do about it, but if it's going to happen, it's going to happen. So some people are just prone to it. I know myself, when I was younger, I got bad car sickness. And again, it's down to that, what they call exposure therapy, just little increments at a time, taking regular breaks, making sure you're well hydrated and all that, not tired. So aside from that, there really hasn't been any issues for us in terms of the content, certainly from the technical side, integrating the hardware solution with the infrastructure that we have in the university. Can be challenging, but I think we found that it is a challenge across multiple universities, just the way that the security is set up and you can't access certain services and so on and so forth. That's been a challenge as well, but it's something that we've been able to overcome.
And are you creating some of the content directly? Because my mind is just going to artificial intelligence and coding from AI and stuff. And is that something that's kind of creeping into your line of work a bit more?
It's mostly off-the-shelf content that we're getting, just because, like you said earlier, we're quite busy. It's as much as I'd love to spend all day creating new scenarios and spaces for students, my time is better spent looking at what's already out there. In terms of the AI side of things, I think that's a thing in education in general that everyone's encountering. And I don't know what the best solution for that is. I think, like any technology, there's benefits and there's disadvantages, but I think it's something that it seems to be here to stay. And I think it would be naive to just say, no, we're going to completely ignore it, pretend it doesn't exist. So it's how do we responsibly use it? How do we introduce it in a way that actually is beneficial to students and beneficial to the staff without or minimizing any of these drawbacks?
Yeah, and I think on the content creation piece as well, Mike created, was it last year or year before, the health and safety piece.
The one for ACE, is it?
Yeah, the one for ACE,
Oh, yes. So when I did 3 months work with ACE, and during my time there, I created a training simulation for complex machine training. Now, my version of it was a simple desk fan, and the idea of that is I brought in a model I found online of a desk fan, and I modeled the different functionality you expect out of the fan, so turn it on and off, changing the speed, oscillation, and then created a suite of testing scenarios for it. So you'd go in, it'd teach you, okay, you need to be putting on your helmet and your gloves for your PPE. This is how you use VR, because that is something that we've noticed. No matter how many applications you've used, you need to have some sort of, this is how you use our application, because while there is a lot the same between applications, you don't know if someone's going into this application having never used VR. And then from there, this is how you use our machine. So while this was a desk fan, your real life scenario may be, a factory machine that if you're bringing in new employees and training them, that's that machine down for 2 or 3 days. Whereas if you had a VR version of it, you can just give them the headset, they can have as long as they want to use it. You're not losing out in profits from taking the machine down. And also if they press the big red button that explodes the whole thing, there's no damage done.
And say it's very intense, it's really interesting what you're doing, but I'm just thinking as well, say on the sustainability side, so you're dedicated full time to this and stuff, so that's a very niche skill, as we were saying, but I can see the advantages for really upgrading education content and experiences. But how sustainable is it in terms of if either of you were ever to switch to another project, how flexible is it to pass on? Or just in terms of other universities following year, very, very good example. You've set a really, really high bar. How feasible is that to adopt?
Yeah, so we're working with the School of Veterinary Sciences at the moment to roll out an application that they got as well, using their own headsets that they procured. So we're looking at that, and all that is from lessons learned and the roadmap we've done, the kind of framework that we've laid out as well. Mm-hmm. Certainly rolling out to other universities as part of the HCI Pillar 3 program that we're involved with. We've started the Virtue Network as well, so virtual immersive reality for transformative university education. So we're hoping that we can pool our resources as a collective for all the programs there and use them to either influence policies or create a really robust framework there for anybody. Now there's questions around primary and secondary school students, can they use them, the age limits, all that kind of stuff, but certainly for universities, technical colleges, all that kind of stuff. So that's kind of what we're building to, is that kind of sustainability piece, the knowledge and the skills and the hardware and the software, all that kind of stuff that we've built up over the last couple of years, that it doesn't go to waste basically, and that is retained and is built upon. Certainly from the sustainability, from an energy perspective, the headsets, they do take up a bit of time to charge, but then again, they last you a long time. But where we find the sustainability advantages for us is we have a tensile strength testing machine, a physical machine that you take pieces of metal and you put it between two clamps, it pulls the metal and then it snaps, and then the student measure the yield strength and all this kind of thing. So we've recreated in VR, so you can physically pick up virtual pieces of metal, place them in this machine, you can run the test, and it gives you exactly, it's based on the mathematical formulas obviously, it plots and it graphs it, so it eliminates the need for us to have a room for the students to do that. There's health and safety issues around that we're eliminating, and there's also the cost of buying the raw materials that we're eliminating as well. So again, the likes of field trips, I know it's not the same as going to a real place and experiencing the sights and sounds and smells, but again, we don't need to hire a bus, we don't need to sign health and safety forms, we don't need to worry about the IP at the other end, because it's all procured, that we can roll that out as many times as we want for however many years. And if, say for instance, the tensile strength testing machine, there's a new version out, all we do is we replace a digital model of it, and that's all you do. So there's almost zero cost there versus €90,000 for this machine.
Yeah, and that's something I didn't think. Sorry, Mike, were you going to say something?
I was just going to say the other side of it is, you kind of alluded to it, the remote learning side of things. So, for example, we had a digital guest lecture. So we had all of the students in a VR application. We had the guest lecturer who was in Limerick, and he presented on his own. We had his slides that we were able to support that side of things, and then all of the students were all in their individual homes. So no one had to travel to campus. The guest lecturer didn't have to travel down from Limerick to Tralee. There was less of an environmental impact on that side of things. And yet the students really enjoyed it. They all found it very engaging, and we ended up having to cut it off early because there was too many questions, you know.
Okay, yeah. So like, would you not see Teams as being able to do the same thing, or what was the difference in the VR there, say?
I think there's usages for both. Where this would be more beneficial is you can bring in more interactive models. You can have a bit more engagement instead of me seeing what's often the case, a bunch of cameras off, mics muted. You had avatars, you could see people actually physically looking at what you're showing them, and you can give them little demo pieces that they can virtually pass around and interact with, and that adds that extra element of immersion for the students. It's not something that would replace Teams as such, but you would have usages where maybe one-off or for a particular lecture or a particular lab, you could have that instead of Teams, or to supplement what you have on Teams.
Yeah, so like it's not an all-out wipeout. We're not saying an all-out wipeout of everything that's traditional and good. It's not a case of bring in the robots.
No, absolutely.
Yeah, I suppose what is being done very well is you're providing the research, and I think if this is going to be implemented successfully into education in an ethical way, it has to be based on research. So it's so new that body of research isn't quite out there yet. But it's great to see that you're taking such an active role in it, and I think the Virtue Network, that's another fantastic step. I know you're leading that, Hans, and for ourselves in the IED Hub, we're doing little studies as well on VR, more to do with kind of biopharmaceutical science and medtech, but there is so many different applications, and beyond that to immersive suites, you know, where you're not wearing a VR headset. Everyone is in one environment, but it's almost like there's a television wrapped around the room, for want of a better way of describing it, where lots of scenarios can be set up and stuff. So is there any advanced technology that you see coming our way that the likes of humble me would not know about?
Nothing springs to mind. I think what we're going to see, or what I hope we're going to see, is a greater adoption and better performance of what we currently have. So you look at, say, you mentioned the Oculus headsets. They came out with the Quest 3 recently enough. And while at face value it's essentially the same as the previous one, it does have a number of extra features, and it also meant that the Quest 2 came down in price, making that more accessible. So it's those kind of things makes it better for wider adoption, and that's where I see things going. It's less, okay, we need to move on from this technology to a new technology. It's we need to get this technology into people's hands, see what they can do with it.
I think so too, and you can see the shift kind of not away from augmented reality, but a number of years ago the HoloLens was cutting edge. It still is. It really is a cutting edge piece of technology, but with the introduction of the better outward facing cameras on the 3s, you're kind of eliminating the need for all that really technical components inside the headset, and it brings the cost value down as well. So I think once you get that blend of being able to augment your reality with information, if it's stats and graphs, if I look at a piece of machinery, I can get the temperature, say for instance, or the RPMs of the motor, and instantly I can diagnose this thing without having to go to a control panel. I think that's where it's going to become key for mass adoption. It needs to get smaller, it needs to get lighter, it needs to get cheaper as well. So the students, they wear the headsets for a maximum 2 hours a week when they're doing their engaged, but still it's a lot of time with the headset on your head, and they become warm. They can become heavy, I suppose, after if you wear them long enough. So until they're maybe the size of maybe a little bit bigger than reading glasses, that's when I see things really taking off.
Okay, and I suppose just kind of finally, is there anything that you see that industry, because both our projects, the IED Hub and Ready, work directly with industry partners, is there a change you would like to see industry bring into kind of maybe improve how us as educators are using immersive technologies?
Yeah, that's one of the goals of the 2-year placement, and the students keeping the headsets then and taking them with them on work placements as well, that if the companies aren't aware of immersive technologies, that the students would introduce them as part of their studies, and hopefully we get some engagement with companies as well. There's a number of companies that we work with around the Kerry area that are not heavily involved, but certainly they are involved in implementing immersive technologies, be it like Matterport scans that you showed us earlier, or just simple 360 content that they annotate with, say, hotspots or overlays. I suppose industry is maybe a little bit hesitant still till it's more of a proven technology that it's really going to save them time, save them money, all those good stuff that industry like. It's not quite there yet, but it's going in the right direction, I feel.
Yeah, I think you kind of hit the nail on the head that they all want this technology to be brought in. They like the idea of the technology, but no one wants to be the first person to bring it in. Yeah. They want it already tested and done, but no one wants to be the one to test it.
And if you were to give one piece of advice to lecturers who are considering maybe adopting more immersive technology into their courses, where do you see the first step of that being?
Identify what you think immersive technology would help with. Because like you alluded to earlier with our remote masterclass, there's things like Teams already. There is solutions there already. If you're going to be bringing in immersive technology for the sake of bringing in immersive technology, you're not going to get very far. But if you have something that you've identified, say you see a particular application that you're like, oh, hey, that could really help with this particular module, and then you go out, test it yourself, you see how it works, and kind of build from there.
Yeah, no, I would 100% agree with that. Like I say as well, it's not the be all, and sometimes a PowerPoint slide is just better than putting on a headset, and there's no benefit to it. Where there is real benefit is if it's going to solve a issue or a problem that you have, get the students more engaged, get their retention up, all those kind of things. That's the real benefit of it.
No, that was really, really interesting, and if you're happy to leave it there.
I certainly am, yeah.
Two very big brains in the room. I feel very impressed.
And I just want to say thank you as well for inviting us down today and showing us
my pleasure
the
entirely.
tour. You certainly have an impressive facility here as well that we're slightly jealous of.
We're proud of it. We're proud of it. But you inspired a lot of it, Hans, as well. So thanks very much. And we leave it at that. So, and thanks very much.
Thank you.